Morning, Wolverines. What we're going to do today is we're going to work with the D-type flip-flop. So I'm on the Logic.li or Logic Gate Simulator website. And when you first go to the website, here's some of the options they have. Since we're building a D-type flip-flop, well, that's actually already pre-built. They have one here, it's the top option, D-latch. So I'm going to click on that. And so here's your D-type flip-flop. It's the two NOR gates that make up any of the flip-flops, with two AND gates and an inverter. As the switch here is what they call the input D, and the other input here, this is a clock signal. And if you sit here and operate it, as I turn this on, and there's a 1 on the output, turn it off, there's a 0. The top light bulb is the output, that's Q. So the bottom one is called Q naught, which it's always the opposite of what Q is. There you get to see here it is. What we're going to do today, though, is that it's not just build this. It's like I said, this is pre-built. What you want to do is you want to copy this. So the way you copy it is do like this. Highlight it. Here's the copy option. Hit copy. Then hit paste. It'll put it down here. What you want to do is move this. Put it back up along here. And then paste again. Move the second one up along here, and then a third time. So you got 3 copies of them. Now what you got to do is on the 3 copies, you need to get rid of the inputs. I said that's the clock signal and the switch. So you just click on them, delete them. Okay, now what you got to do is you got to start hooking these things together. So the way they get hooked together is, see here where this is, you just take this over and connect it to the top there. On the bottom one here, this out one, you connect that right over there, and you just do this for all 3 of them. What this does, I didn't delete this one switch. Let me get that out of there quick. What this does is makes this into what's known as a 4-bit. It's a 4-bit register, or 4-bit computer memory. Each of the circuits individually is 1 bit. And this makes it into a 4-bit memory. Now for this last one here, I'm going to have to kind of wrap it around a little bit. That's just because I don't have quite enough space for it to be completely visible. There. Now what you do as far as this, on these, this clock over here all the way at the beginning, you have to connect it to all these unused inputs, or unconnected inputs now, on these AND gates. So you should have to make a total of 6 lines to get it fully hooked up. There, we have a 4-bit adder circuit. So here's bit 1, bit 2. What you can sit there and notice how it changes as I turn this on and off. If you look, so what it's actually doing is it's shifting the bits through it. Well, that's all for now. Have a great day. See you next time.